In today's lesson, we're going to talk through some of the basic pieces of information that we can get from element location on the periodic table. So really in these next few days, we're thinking about where elements are located and how that location gives us additional information about each of those elements. So here there's really three that we can break the periodic table into three basic components. So the area highlighted here in blue, these are the metals. Metals make up the majority of the elements on the periodic table. So most of the elements found on Earth are metals. The green makes up the nonmetals, and then the purple pink color here, these are my metalloids. So on your own periodic table, I would recommend shading or coloring in these different regions on the periodic table. So go ahead and color in the area of metals. Go ahead and color in the nonmetals. Be careful, make sure you pay attention to the fact that hydrogen is a nonmetal, even though it's located kind of over on the metal side. And then we have our metalloids. I would even draw in kind of a staircase. So for the metalloids, we have boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. So those are my metalloids. I would draw the stair step in your periodic table that I'm drawing here with my red line. So this is really kind of like the line in our periodic table that we see most of our metalloids right along this stair step, and then outside of those metalloids to the right, we see our nonmetals. Outside of the metalloids to the left, that's where we're going to see our metals. So now let's talk about some of the properties that we see for each one of these three categories of elements that we see on the periodic table. So metals, these are ones that you're probably going to be most familiar with. Metals are very useful. We use metals a lot. We see metals all around us. So metals you're going to be pretty familiar with. Metals typically are going to be shiny. So they're going to kind of have luster. They're going to be shiny looking. So think about gold, silver, platinum, even aluminum. Those are all shiny metals. They are going to be solids at room temperature. The only exception here is mercury, Hg. Mercury is a liquid at room temperature. That is the only metal that is a liquid at room temperature. They're going to be malleable and ductile. So malleable means that it can be hammered into a sheet without breaking. So I can hit it with a hammer and it's not going to fracture. It's going to bend, and I can hammer it like flat into different shapes. And ductile means that it can be stretched or pulled into a wire. So think about like copper. I can pull copper into a wire. So copper exemplifies properties of being a metal. Metals are also good conductors of heat and electricity. So there's a reason that we use metals to make cooking pans, because they're going to very easily conduct heat from the burner of your stove up into the contents of whatever you are trying to cook. So they're good conductors. This is also typically why you aren't going to want to like stir a pot of boiling water with a metal spoon, because the heat will travel up the handle of the spoon and it'll get hot when you're holding it. They also are good conductors of electricity. So this is also why we use metals to make wires to conduct electricity through our homes and across long distances as well. So here are just some examples of metals. So we have mercury, that's our liquid metal at room temperature, platinum, magnesium, copper, gold. All of these are examples of metals, and they have all of those properties. So they're shiny, they're ductile and malleable, they conduct heat and electricity really well, they're solids at room temperature with the exception of mercury. So they have all of those metal characteristics. Nonmetals are pretty much the exact opposite. So nonmetals are typically either gases, and a lot of the nonmetals that we see are gases, or they're going to be brittle crystalline solids. And we'll see an example of this here in a minute. So the key word here is brittle. So our nonmetals, they're going to be brittle, and they're going to be dull in color as well. They're not going to be shiny like metals are. Nonmetals are also poor conductors of heat and electricity, so they're not good substances to use for making to making pots and pans. They are not good for transmitting electricity. So these are typically going to be more insulating in their properties. So they're really the exact opposite of metals. Some examples here. So oxygen is a clear, colorless, odorless gas. We breathe it in. So here's a cylinder of clear, colorless, odorless gas. That is a non-metal. Chlorine is another example of non-metals. Chlorine is a gas at room temperature. So here we see this yellow chlorine gas. And then sulfur is another really common non-metal that we see. So it's kind of this yellow, brittle rock, and it has that sulfur smell, obviously. Metalloids are going to have some physical characteristics and some chemical characteristics of both metals and of nonmetals, but they're not really completely like either. So metalloids, typically they might be shiny, but brittle. For example, they might conduct electricity, but they might be poor conductors of heat. Okay, so they have some properties of metals and some properties of nonmetals, but really not a complete set of either. And typically our metalloids, they're going to look kind of like this. So here's boron, germanium, arsenic. These are all examples of our metalloids. So notice how all of these are shiny, but if I were to hit these with a hammer, they're going to be very brittle. They're going to fracture, whereas if I were to hit a chunk of nickel with a hammer, it's just going to bend. If I hit arsenic with a hammer, I'm going to see shards kind of breaking off of it. So there's how we see some of those properties. They're shiny like metals, but brittle like nonmetals. So they have some properties of both.